So here is the problem. Object sliding down an inclined plane. An object of mass m equals 4 kg starting from the slides down an inclined plane of length L equals 3 meter. The plane is inclined by an angle of 30 degrees to the ground. The coefficient of kinetic friction mu sub k equals 0.2 at the bottom of the plane. The mass slides along rough surface with coefficient of kinetic friction mu sub k equals 0.3 until it comes to rest. The goal of this problem is to uh, find out how far the object slides along rough surface. So here is the first question. What is the work done by the friction force while the mass is sliding down the inclined plane? Is it positive or negative? So to solve that, we must find out and calculate the friction force. So before the friction force, we must determine the normal force given by Fn F sub n equals mg cos angle, where m equals 4 kilogram, g equals 9.8 meter per second squared, and 30 degrees angle. So we have the solution. Fn equals 4 kilogram times 9.8 meter per second squared times cos 30 degrees. Cos 30 degrees is equal to square root of 3 over 2. So 4 kilogram times 9.8 meter per second squared times square root of 3 over 2 is approximately 33.95 kilogram, and meter per second squared is just the same. It can be written as Newton, or the same as Newton. So next is the friction force given by F sub F equals mu sub k times normal force, where mu sub k equals 0.2. So here is the solution. 0.2 times 33.95 newtons that we already calculate from the first step. 0.2 times 33.95 newtons is approximately equal to 6.79 newton. So last is cal to calculate or to determine the work done by friction. So given by W sub F equals negative F sub F times L, where L equals 3 meter. So here's the solution. W sub F equals negative 6.79 times 3 meter is approximately equal to negative 20.37 joules. N and meter is just the same as joules. So negative 20.37 joules. So which is negative. So from the question, is it negative or is it positive or negative? So the answer is negative. The work done by the friction force while the mass is sliding down the inclined plane is negative.
As the object slides down the inclined plane, gravity pulls it downward. Only the component of gravity parallel to the plane. To find the work done by the gravitational force while the mass is sliding in inclined plane is first we need to get the force of gravity along the inclined plane. Fg is equals to mass times acceleration due to gravity times sine theta is equals mass, which is 4.0 times 9.8 times the sine theta, which is 0.5. So you multiply it all, then the answer is 19.6 Newton. Then the second is to find the work done by the gravity. So the work done by gravity is equals to the force of gravity times the length of the incline. So the force of gravity, which is the 19.6 multiplied to the length of the incline, which is 3.0, and the answer is 58.8 joules. So this is the work done. This is the work done by the gravitational force while the mass is sliding the inclined plane. The value is positive because gravity helps the object move down the plane rather than opposing it.
Object sliding down an inclined plane. So an object of mass of 4 kilograms starting from rest slides down an inclined plane of length 3 meters. The plane is inclined by an angle of 30 degrees to the ground. The coefficient of kinetic friction is equal to 0.2. At the bottom of the plane, the mass slides along a rough surface with a coefficient of kinetic friction 0.3 until it comes to rest. The goal of this problem is to find out how far the object slides along the rough surface. So since letter A and letter B has nakita na kung what their values and it was answered by my team, so let's now find the kinetic energy of the mass when it just reaches the bottom of the inclined plane. So we have our given here, work by gravity is equal to 58.8 joules and work by friction is equal to negative 20.37 joules. And we're finding the net work or the kinetic energy at the bottom. Now let's solve it. So the solution, we have the formula: net work is equal to work by gravity plus work by friction. So why did we add them? Because the total effect on the block is the sum of all forces doing work. So one is positive, one is negative. Now let's substitute it. So work by gravity is equal to 58.8 joules plus negative 20.37 joules. But since it's negative and positive, positive times negative is equal to negative. So that's why we are going to subtract them. So 58.8 minus 20.37 is equal to 38.43. So this is the kinetic energy the block has at the bottom. So after the gravity adds energy, the friction removes some. So that's why 38.43 joules is our kinetic energy.
So the question in letter D is, what is the work done by the friction force while the mass is sliding along the ground? Is this positive or negative? Friction force in the horizontal surface. When the object is on the rough horizontal surface, the friction force acting on is just equal to U sub k times n. And we all know that the normal force, or the n, is just equal to mg, or mass times gravity. That's why friction force is just equal to U sub k times m times g. This this one. This friction force opposes the motion, so the work done by the friction over a distance d is work of friction is just equal to negative F sub k times d equals to negative U sub k times mg times delta. So the work is negative because the friction force acts opposite to the direction of motion and removes energy from the system.
These are here are the calculation for letter E. How far from the bottom of the inclined plane does the object slide along the rough surface? To find the distance of the object slides along the rough surface, we use the work energy principle. The kinetic energy at the bottom of the inclined plane is equal to the work done by friction on the rough surface to bring the object to rest. So work energy principle. The final kinetic energy K is 0 because the object comes to a stop. The equation kinetic from the bottom plus work done by the friction force ground is equals to 0 indicate that the kinetic energy at the bottom is converted into work done by friction. So the distance D is calculated using the formula kinetic from the bottom is over the coefficient of kinetic friction, the mass of the object, and the acceleration due to gravity. So the values for kinetic energy at the bottom is 38.43. It is already calculated at letter C. The coefficient of kinetic friction is 0.30. It is given. Mass of the object is 4. It is given. Acceleration due to gravity is 9.8. So 38.43 over 0.30 times 4 times 9.8 is approximately 3.27 meter. Thus, the distance the object slides on the rough horizontal surface until its stop is approximately 3.27 meters.